7 miles beneath the surface, where the weight of the entire ocean presses down with the force of an industrial hydraulic press, lies a world we barely understand, the Mariana Trench. While we have mapped the entire surfaces of Mars and the Moon, nearly 95% of our own ocean floor remains a digital ghost, unseen, unmapped, and untouched. Today, we venture into the last great frontier of Earth to separate scientific fact from the echoes of the deep. We descend into the Hadal Zone, a realm of perpetual darkness more than 6 kilometers below the surface. Here the pressure is immense, approximately 1,000 times that of sea level. To put that into perspective, it's the equivalent of having 50 jumbo jets stacked on top of you. It's a force that would instantly crush any land-based organism and even the most advanced military submarines. The water temperature hovers just above freezing, and sunlight has not penetrated these depths for eternity. It's one of the most inhospitable environments on our planet. Yet life does not just exist here, it thrives in forms so alien they challenge our understanding of biology. In this crushing, frigid void, evolution has taken a radical turn, abandoning the familiar rules that govern life on the surface. Survival demands a complete reinvention of the body plan. Most creatures here lack traditional, rigid skeletons, which would shatter under the strain. Instead, they possess gelatinous bodies or flexible cartilage, allowing them to yield to the pressure rather than resist it. To protect their very cells from imploding, they've developed specialized piezolites, small organic molecules like trimethylamine N-oxide or TMAO. These remarkable compounds stabilize proteins and membranes, ensuring that the fundamental machinery of life can function under forces that would otherwise tear it apart. But their most striking and vital tool for survival is bioluminescence. In a world without a sun, these creatures have learned to create their own. This isn't just light, it's a sophisticated biological language, spoken in flashes, glows, and shimmering clouds. It is the primary means of communication and interaction in the abyss. Scientists observe that these organisms use elegant chemical reactions to create this cold light with near-perfect efficiency. The purposes are as diverse as the creatures themselves. For predators like the anglerfish, a glowing lure acts as a fatal beacon for unsuspecting prey. For others, a sudden brilliant flash can startle an attacker, providing a crucial moment to escape into the darkness. This living light is also used for defense, in a strategy known as the burglar alarm. A small creature, when attacked, will light up not to fight back, but to attract an even larger predator that might prey on its attacker. Some species even use bioluminescence for camouflage through counter-illumination, matching the faint light from above to erase their own silhouette. And in the search for a partner, unique patterns of light serve as unmistakable signals, allowing species to find and identify their own kind for mating. Hunting, mating, defense, and deception, all are conducted through this silent, luminous dialogue. It is a breathtaking miracle of organic engineering, a testament to the relentless ingenuity of life. In the planet's deepest, darkest corner, evolution has not only found a way to survive, but has transformed a pitch-black void into a vibrant, pulsating theater of glowing signals. In the crushing silence of the abyss, one physical force reigns supreme: sound. Sound travels over 4 times faster in water than in air, a consequence of water's higher density and near incompressibility. This efficiency turns the deep ocean into a vast planetary-scale acoustic chamber. At a specific depth, typically around 1,000 meters, a unique phenomenon occurs known as the SOFAR channel, or the deep sound channel. Here, temperature and pressure conspire to create a layer where sound speed is at its minimum. Sound waves entering this channel are refracted back and forth, becoming trapped and propagating for immense distances with astonishingly little energy loss. A signal that might dissipate in miles can instead traverse an entire ocean basin. Humanity first began to eavesdrop on this hidden world not for science, but for security. During the Cold War, the U.S. Navy deployed the Sound Surveillance System, or SOSUS, a secret network of underwater microphones called hydrophones, laid across the seafloor to track Soviet submarines. When the Cold War thawed, this powerful tool was opened to civilian researchers at the National Oceanic and Atmospheric Administration, or NOAA. They weren't listening for enemy vessels, they were listening to the planet itself, and the planet had some very strange things to say. In the summer of 1997, the hydrophones picked up a signal of unprecedented power and mystery. Originating from a remote point in the South Pacific, it was an ultra-low frequency sound that rose rapidly over about 1 minute. It was detected by sensors over 5,000 kilometers apart. The sound was so powerful it was significantly louder than the call of any known animal, including the blue whale. Researchers nicknamed it the Bloop. For years, its origin fueled intense speculation. The sound profile didn't match known geology, and its sheer amplitude seemed to defy a biological source. Could it be some colossal, undiscovered creature dwelling in the dark? The Bloop was not alone. Other enigmatic sounds were catalogued, each given a name reflecting its acoustic character. Julia, slow down, the whistle. For over a decade, these were the great unsolved mysteries of the deep. The answer, when it came, was just as dramatic as the speculation. By deploying hydrophones closer to Antarctica, scientists were able to correlate these sounds with the fracturing and cracking of enormous icebergs. These were ice quakes, the groans of continent-sized glaciers breaking apart and scraping the seafloor. The Bloop was the sound of a dying glacier, its immense energy release echoing across the globe through the Sofar Channel. While ice quakes explained many of these famous acoustic events, they didn't explain all of them. A portion of the deep-sea soundscape remains stubbornly unclassified. These are not necessarily loud, dramatic events like the Bloop, but subtler, more localized signals that don't fit the profiles of shipping, marine life, or known geology. These acoustic anomalies pose a fascinating question. In a realm so vast and unexplored, could there be biological or geological processes occurring that our current sensors simply cannot classify? Science doesn't call them monsters. It calls them data points waiting for an explanation, whispers from a world we are only just beginning to hear. We live in an age of unprecedented exploration. We have mapped the surface of Mars, a planet over 50 million kilometers away, with astonishing precision. We have detailed images of Venus, shrouded in its thick corrosive atmosphere, and we know the topography of the moon better than many parts of our own world. So, a fundamental question arises. Why is it easier to map a distant planet than the deep ocean in our own backyard? The answer is both simple and profound. Water, the very substance that defines our planet, is an impenetrable shield to the tools we use to map others. The radio waves used in radar, which slice through the vacuum of space and thin planetary atmospheres with ease, are absorbed and scattered by salt water almost instantly. They simply cannot penetrate the depths. This forces us to use two very different approaches to see what lies beneath. From space, satellites use a technique called altimetry. They don't see the seafloor directly. Instead, they use radar to measure the height of the ocean's surface with millimeter accuracy. Massive underwater features like seamounts and ridges have enough gravitational pull to draw water towards them, creating a subtle bulge on the surface. Conversely, vast canyons and trenches create a slight depression. This gives us a broad, low-resolution overview of the global seafloor, a blurry sketch of the world's largest features. It's how we first inferred the existence of many trenches, but it can't show us the details. It's like trying to read a book by looking at the cover from across the room. To get a true, high-resolution picture, we must go there in person. We must use sound, not light. This is the world of multi-beam sonar. A specialized ship sends a fan of sound waves, pings, down into the abyss. By measuring the precise time it takes for these echoes to return, we can calculate the depth and create a detailed, three-dimensional map of the seafloor below. But this method is painstakingly slow and incredibly expensive. A single ship can only map a narrow swath at a time and must travel at a slow crawl to ensure data quality. Mapping the entire Mariana Trench, a feature larger than the state of California, would require years of continuous ship time, costing hundreds of millions of dollars. The result is a planet where only about 20% of the ocean floor has been mapped with this high-resolution technology. The remaining 80% is a gray featureless void on our charts. This mapping gap is far more than a lack of coordinates on a map. It represents a fundamental hole in our understanding of Earth as a system. Within these unmapped zones lie the answers to some of our most pressing questions. How do deep ocean currents, shaped by unseen topography, regulate global climate? Where are the undiscovered fault lines that could trigger the next great tsunami? What unique ecosystems, thriving in complete isolation, are waiting to be found? Every new expedition to the trench, every newly mapped kilometer of sea floor, doesn't just fill in a blank space, it reveals a world more complex, more dynamic, and more mysterious than we ever imagined, offering clues that could redefine our understanding of geology, oceanography, and even the very origins of life on this planet. Exploration is a battle against physics. When James Cameron descended in the deep-sea Challenger, he described the landscape as desolate and alien. Today, remotely operated vehicles, or ROVs, are our primary eyes. These machines have captured visual anomalies, strange, gelatinous forms, and structures that defy current taxonomy. These are not aliens. They are biological mysteries. To a scientist, a blurry image of an unclassified creature is not a conspiracy. It is an invitation for the next generation of explorers. The Mariana Trench reminds us of our place in the universe. We are a species defined by our curiosity. As long as there are unmapped frontiers and unexplained echoes, we will continue to look down into the dark, not with fear, but with a desire to understand. Because in the deepest parts of our world, the greatest discoveries are still waiting to be found.